In the previous two videos, I have discussed the theory related to um, calculating charges on parallel plate capacitor or parallel plate conductor. The link is given in the description below. And in this video, I will discuss using those theories or those formulas how to calculate charges on various conductors. So this is our first question. Here we have three conductors, parallel plate conductors, given charges as Q minus 2Q, and the third plate, this is our first plate and this is our second plate and this is our third plate. On first plate the charge is given as Q, on third plate it is minus 2Q, and on second plate there is no charge, and we have to calculate the charge appearing on the outer surface of the rightmost plate. So this is very simple question. In fact we will calculate all the charges which are appearing on different surfaces apart from the question or the question that has been asked. So let us consider these parallel plate capacitors 1, 2 and 3. This is our first plate, this is our second plate, and this is our third plate. The notation remains same, that is F1L is representing first plate and this L is towards leftward side, R is towards rightward side. Left is indicated by this red and right is indicated by this yellow color. So initially this Q1, Q2 and Q3 are the charges which I have assumed that they are appearing on these isolated conductors. Now here given is that Q1 is Q, Q2 is 0 and Q3 is minus 2Q, and we have to calculate charges on various faces, that is on F1L, F1R and likewise. In the question it was asked what is the charge that is appearing on face F1L. Now in my previous videos I have explained thoroughly how to calculate QT. QT, I have assumed that this is the charge which is appearing on extreme left or an extreme right. There in my video I have proved that QT that the charges appearing on F1L and on F3R are equal, that is QT, and this QT is sum of all the charges which were initially given to the conductors divided by 2. So in our case QT will be Q plus 0 minus 2Q divided by 2, that is minus Q by 2. So QT, which is the charge which is appearing on extreme left on its leftward face and on extreme right on its rightward face, will be minus Q by 2. I have also calculated the charges which are appearing on other faces, that is F1R, F2L, F2R and F3L. So now notice that initially this plate was given a charge, the first plate was given a charge Q. So sorry, this is our first plate and the charge which were given to the first plate was Q. So we can say that Q equals to capital Q minus QT, and when we substitute the value of QT which we have just calculated, which is minus Q by 2, this small q appears to be 3Q by 2, and from Gauss law we can say that this charge appearing on this F2L will be minus times of small q, that is minus 3Q by 2. Likewise we can calculate QA. Since this plate was initially neutral, there was no charge on this plate, so minus Q plus QA equals to 0, so QA equals to Q, so we can say that QA equals to 3Q by 2. Likewise on F3L the charge that will appear is minus times of QA, that is minus 3Q by 2, and QT we have calculated it is minus Q by 2. You can verify this whether your calculation is right or wrong by considering the charges. This QA is minus 3Q by 2. We can write it as minus 3Q by 2. And QT we have calculated as minus Q by 2. Sorry, QT is minus Q by 2. So when you add these two, you will get the initial charge which was given to the third plate, and that equals to, if you add it, it will be minus 2Q. Thank you. This completes our this particular question. Thank you.